Hello dear friends, welcome to Humble Mak Academy. In this video, we shall be looking at an application of Ohm's law. So friends, stay connected guys, don't miss out on any part on this video because at the end of this video, you shall be able to understand the concept so well guys and use it now to score a better mark in your examination. So guys, my name is Umenju Makarios guys. I'm a part-time science teacher at Step by Step School Complex in Bamenda guys. Okay, now guys, let's look at the problem we have on screen. They want us to calculate the combined resistance of the whole network and the reading of the meter M1, the potential difference across the 2 ohm resistor, and the power dissipated in the circuit, as well as to state and explain how the voltmeter and an ammeter are connected in a circuit. So guys, if you are an O-level student, that is in Form 5, that aims at writing the GC ordinary level as well as writing the WAEC and so other examinations, you are eligible to watch. Even those taking the advanced level guys, you might watch, yes, but you shouldn't expect to see something like this. Okay. Now guys, before I get started guys, make sure you subscribe to this channel guys, because we only help students that have subscribed to this channel to pass the exams with very good grade guys. Join the family by simply subscribing to the channel. Thank you very much guys. Okay, the first part also is calculate the combined resistance of the whole network. Okay guys, let's have the solution. Now guys, we should understand so that generally if we have resistors that are connected in parallel, namely we have this 4 ohm resistor as well as this, they are both in parallel, right? Because at this junction the current has two paths in which it can flow. So it can either flow upwards or downwards. So whenever current has more than one path in which it flows, those components are connected in parallel. And friends, generally for resistors in parallel, if the combined resistance is R total, it never means that 1 over RT is equal to what? 1 over R1 plus 1 over R2 plus dash dash dash. It depends on the number of resistors we have in parallel. But friends, now since if we have just 2 of them in parallel, it never means that the combined resistance R total can be given as R total equal to R1 times R2 over R1 plus R2. Great. That's perfect. Now friends, do you see that the combined resistance of these two networks is in series with the 2 ohm resistor? Note that in series, current has just one path in which it flows. But friends, let's look at how we can get a combined resistance of resistors in series. We should know that for resistors in series, guys, the combined resistance R total is simply given as the sum of the resistances. So we are going to have R total being equal to R1 plus R2 plus R3 plus dash dash dash. It keeps on going depending on the number of resistors we have in series. Okay. Now guys, like I said guys, the combined resistance of this 4 ohm and this 4 ohm are in what? Series with the 2 ohm, right? So it never means that our R total simply becomes, when we use this formula, we have R1 times R2, that's 4 times 4 over 4 plus 4, then plus 2, because of this formula where we have resistors in series. So if we do that, we have an answer of 4 ohms. Okay, let's look at the Roman 2 guys. The Roman 2 wants us to get a reading of M1. Now friends, do you see that M1 is an ammeter? M1 guys is an ammeter. Okay, it's an ammeter because it's connected in series. Friends, I'll explain that later. Okay, now guys, since it is the ammeter and they simply want us to get what the current flowing through this entire circuit, do you see that this M1 simply reads the EMF, this M1, sorry friends, simply reads the current which is made to flow by the presence of this EMF. So it never means that guys, according to Ohm's law is saying that what guys, that the potential difference is given as IR, where I is the current that flows in the circuit. R is what guys? R is the combined resistance of this network. So in that case guys, we are going to have, we make it I the subject, we have I to be equal to V over R. Putting all the values guys, our V is 12 volts, our R is the combined resistance which is 4 ohms. Doing that guys, we have I to be equal to 3 amperes. That is the current that this M1 reads. Okay, now guys, the next part, which is Roman 3, wants us to get the PD, or the potential difference across the 2 ohm resistor. Okay, now guys, we are still going to be using Ohm's law, which is saying that V equals IR. Keep in mind that our V in this case is the potential difference across the 2 ohm resistor, our I is the current that is going to be flowing through these two ohm resistor, which is definitely going to what the rating of M1, right? Because the current flows from positive to negative. It flows like this. This current flows through this two ohm resistor. It enters into this. When it reaches this junction where this laser is, it splits into two. One comes up, one comes down. They both still come and join at this point, and we still have the current here. So we are going to have our R now to be the combined resistance of this whole network. So if we plug in everything, guys, since they want us to get the potential difference across the 2 ohm resistor, means our R in this case, that's what, guys, has to be 2 ohms. So if you plug in everything, guys, we have our V, which is the potential difference across the 2 ohms, to be equal to 3, which is what, guys, the current I. R is what, 2. So doing everything, guys, we have an answer of 6 volts. Okay, now, guys, let's get the power dissipated. Generally, to get a power, friends, power is given as IV, or we can get our power P to be also the same as I squared R. But friends, we are going to use the first one. Use the second one, guys, and tell me if your answer is the same in the comment section down below. So if we plug in our values, our I is 3, our V in this case, guys, is 12. So we're going to have an answer of 36 watt. Keep in mind that power is measured in watts. Okay, then now, guys, if we go to the next question, which one is also state and explain how a voltmeter and an ammeter are connected in a circuit. So friends, generally an ammeter is connected in series because it has a very low or a negligible internal resistance, while, friends, a voltmeter is connected in parallel because it has what, guys, a very high internal resistance. So, guys, that's it for this our question. If there's something you don't understand, if there's something you need more explanation, guys, leave it in the comment section down below. I'll get back to you as soon as possible. Have a blessed day.